Okay, so we're going to look at using the sum and difference identities for proofs. Okay, so they're there. Be sure you have them listed somewhere or you have your formula sheet. So here's our first one. And when we use these, we're always going to end up using sum difference as the first step. So if you look at the identities there, we have our sine of x plus y, which is going to be my green highlighted guy. And then I'm going to plug that in, right? So I have a cosine there, and then I'm using the identity for the green. And then I have a minus sign, and then I'm going to use the blue guy, right, to split that guy up. And my reason there is sum difference. So again, that sum difference is typically going to be our very first step. Now, notice we need to distribute, and pay attention, that's a minus sign that we're distributing there in the middle. So there's my distributive property, and my reason there is just algebra. Now notice that we have two terms that will cancel out, right? And those would also be algebra, so I could omit them, right, when I type it into Alex. So there's what I would be left with, right? Cosine squared sine y plus sine squared sine y. So that would also be algebra. And then notice that we have a common factor. Since we have a common factor, we can factor it out. And that would also be by algebra, right? And then remember, cosine plus sine squared is 1. So we're left with sine y by the Pythagorean identity. And then again, remember, you could go ahead and not put those two steps in Alex, right? You would need to, they've got to be part of your thought process, but they don't need to be typed out in Alex because all three steps there use algebra. Okay, next one. Oh, so on your cheat sheet then, we want to add underneath algebra, we want to add sum difference. Okay, next one. So here we have a fraction, and I'm not going to bother to write it as horizontal division just because it's going to take up so much space because the identities are so long. So I'm using the blue guy to identity here. So that's just me writing it out, right? And there's my reason is sum difference. Notice on the right-hand side of our identity, we have a plus sign. So that means we're going to need to split this guy into terms, right? So there's just doing that, right? And I called it algebra, but I'm just splitting the terms. And then notice in each term, I have some stuff that will cancel out. So I could go ahead and cancel them out and then just type what's in green, right, in Alex as my algebra step. And then notice I already have my tangents, right? Tangent x, tangent y by quotient. So again, when we use that sum difference, it's going to be that first step. Okay. All right, so this one is interesting. We have a pi in here. So first, let's go ahead and use the identity to break it out. And there we go, right? So then we want to think about pi. Well, pi is the ordered pair -1, 0. So if you think about it as plugging that in, the sine of pi is 0 times cosine x plus the cosine of pi is -1 times sine x. And so what did we do? We don't want to say algebra. What we did here is we used evaluate. So we evaluated the sine of pi. Now we can go ahead and simplify it out, right? And so we know that 0 times anything is 0, so I'm left with just negative sine x by algebra. You do have to put the step of plugging in that 0 and that -1, even though you know that 0 cosine x term is going to go away because that's how you show the evaluate step. So now on your cheat sheet under sum difference, you want to add evaluate. Okay, again here we're going to evaluate. And again, I'm not going to bother with horizontal division because it will take up so much space. So I'm going to go ahead and leave it compound. For these, it's usually fine to do that because things will cancel pretty easily. So we are using that top one for both of them, right? They're both cosine A plus B. So there we go. And that's some difference, right? And so now we need to think about both pi over 2 and pi. So pi over 2 is 0, 1. Pi is -1, 0. So plugging in, I have the cosine of pi over 2, which is 0, times the cosine of x, minus the sine of pi over 2 is 1, times the sine of x, all over the cosine of pi is -1, times cosine x, minus the sine of pi is 0 times sine x. And that reason is evaluate. And again, you have to put in those 0 times, right? The 0 times and the 1 or -1 times to indicate that you are using that evaluate step. Okay, so now I can go through and deal with the stuff that equals 0, right? So it's all gone. And I end up with negative sine over negative cosine by algebra. You could also go ahead and just make that positive, right? Because we know negative over negative is positive, and that step is algebra as well. And then we have tangent by quotient. All right, now I have a pi over 6. This seems kind of weird, right? But we're going to go ahead and do what we've been doing and use my identities to work it out. So I have 2 different ones there, so I want to be careful with my signs, right? But the sign in between is plus, so that's good. If that sign in between had been minus, we would need to be really careful when we put that identity in. So there's my orange guy, right? He's going to be really long. And then plus my green guy. Again, if that had been a minus, we would have wanted parentheses around our whole green guy, right? And then we would have had to distribute that negative in. So my reason there is some difference. Now notice I have some stuff that will cancel, right? So I'm going to go ahead and cancel it and rewrite it. Now I could have just written it as sine pi over x cosine x plus sine pi over x cosine x. It doesn't matter. I just went ahead and made it 2 sine pi over 6. Okay, now we want to think about our ordered pair for pi over 6, which is root 3 over 2, 1/2. So now is my evaluate step. I'm going to keep my 2 out there, right? And then do my evaluate of the sine of pi over 6, which is 1/2 times the cosine. And that's evaluate. And then I'm left with cosine by algebra. Okay, one more. Tangent of pi minus x. So the tangent guy, his identity is a fraction already, right? So just using that identity, there we go. And my rule is some difference. Now I've got to think about the ordered pair for pi. Pi is -1, 0, and tangent is y over x. So the tangent of pi is 0. So now for my evaluate step, I'm going to go in and put in the zeros for the tangent of pi. But notice those zeros are in there. They have to be in there to show that you use the evaluate step. Okay. And so then I can clean it up and I'm already done, right? Negative tangent with algebra. Hope these are fun and quick for you.